Welcome everybody to our latest Critical Conversation event. My name is Hayaatun Sillem and I'm the CEO at the Royal Academy of Engineering and the Queen Elizabeth Prize for Engineering Foundation. And it is my great pleasure to be hosting another one of these online fireside chats that we run to explore topical issues that are important for engineering and for society. Our overarching goal at the Royal Academy of Engineering is to harness the power of engineering to build a sustainable society and an inclusive economy that works for everyone. And we've used these critical conversations to look at some of the engineering challenges and opportunities that will be crucial to addressing this goal. Engineers play a profoundly important role in designing, delivering, and maintaining the products, the services, the infrastructure, both digital and physical, that underpin virtually every aspect of modern life. And as such, it is vital that countries around the world can access the quantity, the quality, and the diversity of skilled engineers needed to meet the requirements of the economy and of society. Back in 2019, as part of the Engineering X collaboration, which we at the Academy co-founded with Lloyd's Register Foundation, we published the first ever Global Engineering Capability Review, and we're looking forward to publishing our next iteration of the Global Engineering Capability Review in the coming months. What these global reviews clearly show is that while every country faces specific engineering skills challenges that relate to their particular environments, contexts, education systems, economies, there are also clear cross-cutting challenges, not least the need to keep pace with rapid technological change and ensure that engineers have the skills to tackle shared global challenges such as climate change. We're also looking at these skills challenges at a national level, in particular through our Engineers 2030 project, examining what and how we teach future and existing engineers and technicians, with colleagues right across the engineering profession through the National Engineering Policy Centre. We'll be exploring whether the systems, cultures and policies in place across the UK are able to deliver what we need from our engineering and technology workforce for the next 25 years through two phases. Firstly, defining the knowledge, skills and behaviours of the future engineer, and secondly, using systems thinking to understand how the education and skills system will need to evolve to deliver these knowledge, skills and behaviours. And today, I'm delighted that we're going to have the chance to get to grips with the crucial question, how do we create engineers with the skills needed to tackle the challenges of today and tomorrow with the help of three brilliant experts? We're joined by Dr Tim Slingsby, Director of Skills and Education at Lloyd's Register Foundation, an independent global charity that supports research, innovation and education to make the world a safer place. Rosa Wells, Principal and Dean for STEM at University College Birmingham, a Board Director for Greater Birmingham and Solihull Institute of Technology, and Deputy Chair, Education and Skills Advisory Panel for the Engineering Council. And Dr Dorothy Okello, Dean of the School of Engineering, Associate Professor of the Department of Electrical and Computer Engineering at Makerere University, and former Director of Innovation at Resilient Africa Network. Delighted that you can join us and really looking forward to our conversation. So I think we should start by unpacking the problem a bit more. What are some of the issues with the current approach to skills building for engineers, and what kind of differences do we see when we look across the global picture? Perhaps, Tim, you could kick off on this one.
Thank you. Yes, get the easy one to kick off with, don't I? I think fundamentally there's a problem with how we talk about skills at a number of levels. And most recently, I really started to struggle with the phrase or the acronym STEM as a catch-all term for all of the technical skills shortages we're starting to see around the world. You know, for example, we see stats thrown around like 3.5 million STEM jobs are needed in the United States by 2025. Well, specifically, what skills and where and in what sectors? So the scale of the challenge is so huge that I think STEM itself is far too vague a term for us to be able to match specific skills with the emerging jobs. And I think this lack of clarity really discourages targeted policies and investments that can reduce the skills gap. So for a bit of context, and even digging into just engineering, we get quotes from UN agencies and others who tell us that 10 million more engineers are needed in Africa over the next 20 years. So even if those numbers are accurate and can be justified, again, it boils down to, well, specifically what skills and by when, how quickly are they needed, and who can design the programs that's going to close that gap. By 2050, just to give some size of the scale of the challenge again, by 2050, we're going to need assets underpinning energy generation, energy delivery, communications, transport, and so on, with an investment of nearly $50 trillion. So that's an enormous scale, several times what currently exists in the whole of Europe in just 20 years. And at the same time, we've got to adjust to a changing climate, and we've got to cope with the future of work as we bring in the digital transition, the energy transition, the increasing use of autonomy. We did have a report back in 2018, I think it was by Dell and by the Institute for the Future, that said something like 85% of the jobs we'll do in 2030 haven't been invented yet. So that certainly speaks to a disconnect between education and the job market. And so to me, that's why it's important to build and strengthen the evidence base. So at the foundation, for example, we might ask, where's the most potential benefit to safety? And then what evidence is available, and what are the gaps? And then how do we act at scale and pace? And you mentioned the Global Engineering Capability Review, Hayaatun, and thank you for doing that. I think that's a really positive start to strengthening the evidence base about how we can actually address this issue. The first one, you rightly pointed out, we published in early 2020, but it didn't get that much attention because just after we published it, COVID hit and everybody's attention was quite rightly elsewhere. But nevertheless, that gave us a clear picture of missing data and the difficulties we've got in actually building up the picture of what the gaps are and where they are. I think the new one, which is even stronger in terms of the data sets we've relied on, which, as you say, we'll publish in a few months, will be a really fantastic start. We can already see a clear correlation between engineering capacity of a country and safer engineering outcomes. We know that within this engineering capability review, we're going to have an engineering capacity index, and that will give us benchmarks for capacity in 115 geographies around the world and identify the critical capacity gaps that we will be able to use to improve engineering capability. I think one thing to draw out of there before I finish talking is that only 7 of those 115 geographies, if I remember my preview well enough, have the highest capacity for safe engineering. But there are indications that lots and lots of other geographies actually have strengths that are underutilized or constrained. So to wrap up, I think the challenge is huge. STEM is far too vague a term, and it leads to a huge disconnect between education, training, and the jobs that we'll actually need to be doing now and in the future. Specific evidence is needed for effective change, and in that space, the Global Engineering Capability Review will be a great start.
Great, thank you very much, Tim. So you've sketched a picture of a large and complex challenge that we're not being specific enough in the way we articulate and interrogate. We've got this disconnect between education skill system and the jobs, or the job market of the future, and we've got a lack of data and evidence. So Dorothy, this is not an easy starting point. Why does all this matter? What are the impacts of skills gaps and shortages on people, on the environment, on the economy?
Yes, thank you, Hayaatun. And indeed, it's a major issue because, one, it means that our graduates coming out into the field are not able to contribute effectively as they come out. Now, I'm not saying that we can train engineers and immediately day one they can fit into any industry or company or anything like that. But actually, even a study that we have done ourselves with the support of a UNESCO project that's running in 6 countries in Africa, we did a labor market analysis under that and were able to clearly show the gap between what the industry needed and what we are actually generating. So that is one issue. So it means that you're sending out people that are not quite ready yet. Then also the other issue that we have to deal with is that there are so many other considerations that we have to take into account when we look at training engineering graduates. What has come up earlier from Tim, for example, issues around how do we really embed issues around safety so that right at the word go, our graduates are very conversant with the key issues around that. Yes, we do some, we need to be doing more. So that is another issue. So if you're sending people out there, and I think today's engineer. Also, there's a little more that flexibility, creativity that we're allowing for. So you're working within that space. The other issue that we need to look at is also the issue of embedding humanitarian engineering as part and parcel of what we are doing in terms of our training. So you will have a civil engineer going out. I know how to do bridges. I know how to do roads. What happens when I'm in conflict situations? What happens when we have disasters? How do we quickly resolve our graduates to be able to handle scenarios such as that? So these are some of the issues that we have to address. The other impact that you get is that you have our students talking about that, oh, I really love going for these hackathons, those challenges and all, but that's all part of engineering. But you can see even at their own level, they're sort of looking at innovation challenges, hackathons, being a much different thing from, what we're doing in terms of our engineering training. And yet it should not be, because engineers, we are problem solvers. So that should be actually part and parcel of what we are doing in terms of preparing our graduates for the field, in terms of how we are training. The other key issue or impact on this is related to the mobility of the engineers, because and Tim did put out the numbers quite there. There are all these different spaces that will have, we need so many engineers globally. We need so many engineers in Africa. But if you look at actually granularity in terms of maybe regions or countries, some regions are producing more actually than they need. But how do we manage the mobility in order to get engineers exactly where we need them? Or we have a disaster in a certain area, it's close by. How do we quickly mobilize our engineers? Now, that means that we need to have standards. Okay, and so if I may pick out one, for example, the Washington Accord, which is one of those globally accepted. But if you look at within the region in Africa, very few countries are actually having engineers trained to that level. And if you look at what it takes to train our engineers, for example, we did a study in Uganda as well. What would it take? We would have to go down to our secondary school, revise what we are doing at that level before we even come to the level of the university, which is where I'm at. And actually, with the support of the Royal Academy of Engineering and the African Federation of Engineering Organizations, there's been some work done as to, yes, with our curricula and our training the way it is, what more can we do to try and, close the gap between the training we are having, the skills that our graduates are coming up with, and where we need to be in terms of aligning with the Washington Accord, taking into account the training that has been had, so that we can quickly come and close that gap because of the impacts that then it has, our readiness for industry, our ability to respond to emergencies, using our homegrown engineers and the talent that we have locally available. So I will stop at this point for now. Thank you.
Dorothy, thank you. You raised so many important issues that we're definitely going to try and pick up on. I want to turn to Rosa to bring you into the conversation as well, and also to flag to our audience that we absolutely want to be taking your questions. So please do drop them into the chat and we'll pick up as many as we can. But before that, Rosa, I'd like to turn to you to think about not just where we are today, but looking ahead, say, to the next decade. How do you see our engineering skills needs changing?
So I think a good way to sort of set this off is to look at that Engineers 2030 framework, which has been published. So that sets everything in the scene of people, planet and prosperity. And I think we've been doing a lot of thinking recently about public perception around engineers, what attracts people to becoming engineers. And I think sometimes engineers are led by the technology and the excitement of doing things because the technology leads them there. And I think we're now in more of a space where we need to think about the ethics and the sustainability and the global impact of the decisions we're making. And I think if we start to move into that space, that will really help potentially with that attraction piece, because it may attract different sorts of engineers into the sector who have different objectives. We know that We've got various technological challenges, the growth of AI. What does that mean for engineering and the training that we design? So when we're designing our courses, and I design courses from everybody from entry-level skills through to postgraduate, so I've got a broad range of things to think about. How do we support our learners, whether they're in work or preparing for work, to think about how those new technologies can support them, and how do we authentically assess those skills to make sure they're ready for work? And I think it's about bringing the skill set up. It really creates opportunity to develop those analytical skills, being able to synthesize information, being able to judge what is reliable information. And as we move into, and as we look to support industry to adopt more technologies around automation and robotics, particularly for manufacturing, which can help productivity, we need to think about how we support engineers to work in a more multidisciplinary space. So here, I've been designing undergraduate degrees in electromechanical engineering so that they have both disciplines and not just one. And I'm also developing courses for the automotive sector in battery technology, which requires much more understanding of chemistry than maybe we previously taught. So it's about academics keeping up to date and updating courses, and supporting our residents. So I work closely with people in Birmingham to raise the skill levels as well, because we know that actually this provides better work. And so if we really value the different levels of engineering and the profession and support people to develop through that, that's how we're going to build that pipeline and hopefully really answer that challenge that Tim set there at the beginning.
Fantastic, Rosa. So I would like to come back to your points around technology and multidisciplinarity very shortly. But first, I'd just like to take a minute to drill down a bit further into the concept of safety skills. So through Engineering X, our collaboration with Lloyd's Register Foundation, we've been particularly concerned about engineering safety skills and the maturity around the world. And we see this significant variation in the degree to which safety skills are prioritised in different countries. So Tim, could you just tell us a little bit more about the extent to which safety skills are embedded in engineering education and ongoing skills building, and maybe a bit about how you would like to see that changing over time? And then I'm going to try and start bringing in audience questions, so please keep those coming. Thank you.
Yeah, how are they embedded? Well, that's again easy to say, difficult to do. I mean, first of all, I think we have to highlight why safety matters so much. It's perhaps obvious to those of us who are more directly involved, but without a safety culture and safety process and standards for safety, people die. There are 1,000 people a day around the world dying as a result of an accident at work, and that not including work-related ill health and things. So it's vitally important. We have had a couple of instances in which we are trying to embed a better safety culture within engineering education, for example. So, the Engineering X partnership that you've mentioned a few times, we have a network of people in education institutions around the world, mainly in sub-Saharan Africa and Southeast Asia, that we're calling our safety champions in engineering education. And they're aiming to improve the quality of teaching and learning that enhances safety and sustainability within engineering practice. We're also in conversation at the foundation with the Engineering Professors Council about how we might address the growing emphasis on safety that we see within accreditation processes around the world. So how do we go beyond plant and site safety, for example, and start looking at safety from design to the end of engineered life, which is another Engineering X program, of course. So how might we develop a toolkit that can help those within academia to better integrate a safety-first approach into the education of our future engineers? There's loads to do. It might be driven by an ethical and moral values. It might be driven by regulation. It might be driven by understanding the value of safety within the industry workplace, for example. I know that at the foundation, colleagues have partnered with Delft University and with the National Safety Council in the States to better understand the value of safety across various sectors and industries. So there are steps being taken. We're a long way to go, but I'm very hopeful and optimistic.
Great, we can all do with a bit of optimism. I'm going to just, before we go to audience questions, I promise we're going to go there very soon, just touch on this issue of technology, because it obviously is impacting on both the skills we need to foster in the engineering workforce and also the role that engineers play in developing the technologies. It's very hard to disentangle the skills discussion from the technology discussion. Dorothy, what opportunities can you see for technology to help us with our skills challenges?
Yes, Hayaatun, that's a really good question. And just let me take us back a bit, at least in our context. COVID was a really bad thing, but one of the things it did is that it really made blended learning or learning online or training online normal. We came to accept it, and it led to a whole plethora of tools that we can use to get this done and do it well. So the first way that technology therefore enables us is that by offering the opportunity for blended learning. So you have in-person and you have online sessions and, this kind of thing. So it means that we are more able to match the availability of our learners and even provide opportunity for self-paced learners. So that is one way that technology is supporting this. I think also technology is opening up a whole world. I often tell my students that my role really in the class is I'm a facilitator, and I expect to learn from them as they're going to learn from me, because we all have access to the same Google and all this. So I mean, they have the course outline. They could check out everything out there and come out smarter than me on a particular issue. No problem. We will discuss, we will interact. So I think that is a good thing. I think also it brings in tools that enable us, especially with our resource constraints, to enhance the training we have available. So we have virtual reality that we can take advantage of. We have ChatGPT, and I know in academic circles, especially around ChatGPT and AI, there are a lot of discussions about the good, the bad, and the ugly. But I advise my students that, as far as I'm concerned, ChatGPT is a low-cost research assistant. Take advantage of it. Just don't reproduce what you get out there as your assignment. We have also the opportunity for virtual labs. We have virtual, so we can have a lot of experiences that enable us to immerse our learners into different worlds, different experiences, and different opportunities. Also, it facilitates micro-credential systems so that even while they are following along with the curriculum and there's slow changes to our curriculum, as it were, they can have all these micro-credentials that they're able to take by virtue of technology. We are working on a program with one of our partners where we'll even do training on soft skills, and they'll be having all these report cards that they can verify as to what they're able to do and not to do. And I think, therefore, technology provides us all those wonderful opportunities in order to try and reduce the gap, allow quick catch-up where new technology comes in, and also new needs from industry we can hopefully better match together with our curriculum that we are training. Thank you.
Brilliant. Again, a lovely optimistic note. Rosa, just very briefly, Tim talked earlier about the fact that we all know that the skills we need is a moving target. So how do we adapt our curriculum and our approaches to learning and even accreditation to take account of the fact that the engineers we're training will need to adapt throughout their careers to keep pace with technological developments?
Yes, I think this is the tricky bit, and this is something that we need to think about. The behaviours we mentioned at the beginning, knowledge, skills and behaviours, and sometimes we fall into the trap of saying every learner needs to learn this particular programming language or this particular CAD package, and actually what we need to be doing is developing learners that are able to adapt and pick up new skills. And that is more difficult to do, but that really needs to be the focus, so that they have confidence as they move through their careers, that they can identify where they need to spend a bit more time learning something new. They know how to find that information or find that training, and supported by their employers. So I think we do need to think a lot about behaviours and not just transfer of knowledge within curriculum. That is something we really need to develop, and we do need a commitment to lifelong learning. We know we've all been working for some time, and you have to learn as you go, and it's particularly important in engineering that we keep up to date with those new technologies as they develop and are introduced.
Yes, Rosa. I mean, I think we're in a situation where clearly we can see the relative value of knowledge acquisition has declined. And what we need to do is be people who can learn how to learn and actually enjoy that process of having to adapt, having to be resilient to the changing skills needs. Tim, I'll come to you in a minute. I just want to stay with Rosa. I'm very keen to start bringing in audience questions, having promised to do so. So maybe stay with you, Rosa. Julian Coyne is asking about how we can elevate public perception of vocational and trade skills, which of course are such an important part of our engineering profession. Do you have any thoughts on this question?
Yes, so I do have a lot of learners in this space. Electrical installation is actually hugely popular. Our biggest challenge is finding really talented lecturers to teach it. But I absolutely get the point. Engineering is a complex sector with many levels, and we need to value the skills that come with the trades, as well as the influence that graduate engineers have on the sector and some of the design. I think this is an issue in some countries more than others, and I think it is a particular issue in the UK. I've been fortunate to be invited on some world skills exchanges with other countries to compare skills systems, and we have a real challenge in the UK around parity of esteem for vocational versus academic routes, and also a challenge in deciphering the vocational routes. Confidently, parents, young people, employers struggle, and I think it is an area we really need to work on. I know through IFE, which is the Institute for Apprenticeships and Technical Education, they've been looking at identifying standards and occupational standards that we align our qualifications to. There is still quite a lot of work we need to do to get that right and that working for everybody across the different areas. But there are some aspects, certainly electrical installation is very popular with young people and their parents, but there's others that are less well seen, actually. It's those that are probably more behind factory doors, maintenance engineers, and those that support with some of those technical aspects that are more difficult to get people into.
Thank you, Rosa. I'm going to come back to Dorothy and you in a minute on the question of standards. There's a question from Ali Shahade in the chat, but I'm going to go to Tim first because I know you wanted to come back. So feel free to top up on any of the topics that we've been discussing so far.
Thank you. Well, first of all, I think Rosa just made an excellent point about, I suppose, the culture of esteem within the UK. I think that's certainly the case. We have a program at the foundation that focuses on very basic engineering skills within Southeast Asia. We're trying to train 10,000 people to act safely within basic construction skills, inspection of welding, and this is in partnership with TWI, basic OSH skills, and that's oversubscribed. The demand for those skills, partly because of the amount of infrastructure that's being built there as well, of course, is huge. So I absolutely agree about that culture of esteem in the UK. I think that the technologies available to us, as Dorothy was saying, and again overlapping with what Rosa was saying, also provide an awful lot of opportunities. This lifelong learning and agile learning landscape that is now available to us, if we can better embrace digital passports and digital badges and skills passports as part of lifelong learning, and really, no matter where we are in the world, be locally led. You know, we have things like local skills improvement plans that are specific to the local needs. I think that would be a huge step forward. And then there was another point which has rapidly raced out of my head, so I'll come back to you later.
Don't worry, you'll have another chance to share your thoughts. But Dorothy, maybe I could come to you. There's a question from Ali Shahade about how we can ensure that we can have education programs that and standards that adapt to future technological advancements. And I know you've got a lot of views on standards as well. So do you want to share some of those perspectives with us, Dorothy? And feel free to come back on any of the other topics we've just been talking about.
Okay, thank you. Yeah, I think in the academic setting, that's a really good question. And it's something that we have to continue to innovate around because, you know, once you come in for a curriculum, you're going to do, so engineering is 4 years program or 3, depending on where you're at. So what you start off with is what you're going to finish off with. All right. But in 3 to 4 years, so much can change. Okay, so what that means is that, yes, we accept that, yes, we have our 3 to 4 year cycles for the curriculum review, but that curriculum should be designed in a way that is flexible to accommodate time for also injection of new skills as needed along that. And this is the whole opportunity for the micro credentials that come along. And so it has to be, the curriculum therefore must be designed with opportunities and space for that. That is one. The other is constitution of academia industry panels, or in some other places I've heard them called future skills needs, that are continuously monitoring what is the curriculum, what are we teaching, how are our graduates doing vis-a-vis how is the industry changing. Because normally what happens in the curriculum review process is that you have certain touch points where industry and academia get together to engage on the curriculum and see how we change. But with the rapid changes that are going on, these can't be points along a process. This has to be an ongoing engagement. And this is why I talk about academia industry panels that are part and parcel of the curriculum process, all the way through inception, running, evaluation, and then its revision, so that we are quickly able to ramp up. The third piece that I want to bring in, and I see Yewande has touched on it as well, is the whole issue about the provision of sufficient opportunities for internship or industrial training, because on the one hand, I can appreciate it, because if I look at my own country, where before we had Makerere University as the only university generating engineers and whom they had to accommodate, you have now, 4 or 5 of the big universities in Uganda. They're all pumping out engineers. And so, this same industry will say, okay, I'm giving you a quarter of so much, so that they can accommodate everybody. So we need to come up with, number one, incentive mechanisms so that industry itself can see how it's of value. So we need to have a good value proposition for industry in terms of being able to take on more. We also need to innovate around the kind of training opportunities or industry exposure that we are making available. We tried an experiment where we were looking at having our students in 3rd year going on to their final year, if some of them would opt instead to take a 1 year in industry, okay, and then come back and do their final year. Of course, that would mean that their degree program would then be 5 years. And when we marketed this, pitched it to the students and their parents, this looked very exciting. When it came to actually signing out to join the industry program, even if they were going to get paid, because sometimes they're like, oh, young people will move where the money flows. It was like, you mean I'll actually graduate after my peers have graduated? And that became a big issue. And so the people that actually, or the number that signed up vis-a-vis the people that opted for that program changed. But what it showed us is that actually we can innovate around how we do our industry engagement, even when the numbers are ballooning in terms of our graduates, and our industry space may not be growing as fast as it is. So we need to figure out how we actually work within that space. So I think I've put more questions out there than I've answered, because this is a huge problem that we need to really tackle heads on. Thank you.
Thank you. Well, I mean, Dorothy, those are important questions to be reinforcing. And in the UK, we've also had the challenge of T-levels requiring work experience, sort of placements that have not been easy to deliver. Rosa, I think I'd like to come to you. I'm going to slightly unfairly ask you to wrap in a response to Yewande Okello's question about work experience, and also going back to that standards question, which I think we didn't quite manage to completely cover off. And so Nigel Hargreaves effectively asked us, how do we make sure that we have agility in standards, not just in the education we're delivering and the ability to micro-credentialing and so forth. So Rosa, I'd love your thoughts on both of those questions and anything else that springs to mind right now. Trying to get to as much as possible.
Okay, I'll start with the work experience and the T-level. So I have T-level learners in engineering, and it is a real challenge getting them the placements that they need. And so we really do need to think about how we support that. Interestingly, the sectors are split. So manufacturing engineering is incredibly hard to get our learners into, but our construction engineering, civil engineering, building services is much easier to engage with, and it might be worth looking at some of the incentives for that. So because the construction sector generally is bidding for contracts and often public sector contracts, and that then comes with a requirement for social value, there then is a driver for those employers to engage with us on T-level placements, and actually that's working really well, and our learners are benefiting from that. So there might be something we can do there if we can try to replicate that across manufacturing. We're doing something in Birmingham with our Institute of Technology, which brings together all of our universities and colleges together and it specialises in engineering, to support employers. So one of the things we hear from employers is landscape's too complicated, we don't know how to engage or who to engage with, there's too many of you talking to us. And certainly we found that with T-levels, we have T-levels all over Birmingham, T-level learners all over Birmingham. We're bringing them into one hub that learners can come, employers can come and meet them, set projects, and then support them into a placement. So I think, again, there's something we can do there to support that side of things. But it is absolutely essential, that work placement, that work experience, and it is often most difficult, as Dorothy has said, for those that maybe those are less affluent students, those that maybe struggle financially from more challenging backgrounds, to be able to engage with those placements. So we really need to think about that to provide that parity of learning access to development for all of our learners. In terms of standards and agility, I think that is a challenge, and I think that's when, so we are relying in the UK on IFATE. But I've been listening to other countries and what they're doing, and I know in Switzerland they really rely on industry advisory bodies to inform the curriculum that's relevant to that sector, support educators to upskill, and support their employers as well to engage and provide the placements. I know Switzerland's quite a different economy to the UK, but there might be something we can learn there from how we use those industry and trade bodies and our professional engineering institutions to support us in adapting, because it is a long process in the UK particularly, and I don't know about other countries. Once a standard is in place, it's hard to update that quickly and at the pace that is needed. Certainly we're seeing that at the moment with green technologies. It's hard to get them into some of the standards that we'd like to see.
Thank you, Rosa. And just to reiterate that, this is something that's on the agenda of the UK engineering community, certainly. So the Engineering Council and the professional engineering institutions are all deeply concerned and engaged in thinking about this. I'm going to come to you, Tim. There's so many questions I'm trying to get through. Peter Anderson asked a question about how we can better communicate this role that engineers can play in delivering societal value and solving the things that really matter to all of us. So have you done a lot of work in that in the context of Lloyd's Register Foundation, and particularly, I guess in the context of safety? How do you get the message out there that engineers are these key agents for positive change?
Well, it is a challenge, that, and of course, I'm going to borrow something you've said before, Hayaatun, and which I've repeated at dinner parties, and this is very much in a UK context. We often hear about engineering in the UK in a negative context. You've said before, we only ever hear about engineers on the railways with relation to engineering problems causing a delay to your trains. Why don't we hear that, your trains arrive safely and in one piece without falling over because of engineering? So I think there is a role for all of us involved with engineering and who do see the value of engineering to better express the positivity that it can bring. And also the way in which engineering is such an integral part of everything we do every single day. The critical infrastructure we all rely upon for communications, for trading, for energy, it's down to engineering. So I think people do see it as soon as it's said, and I think we're not too far away from it being better realised. I can't remember if it was Dorothy or Rosa earlier on I think it was Dorothy who made the link between engineering and humanitarian relief as well. It is such an integral part of our society and our response to the challenges we face. If you look, for example, at the green and digital transitions that we're all going through at the moment around the world, within there are some of the world's biggest safety challenges for the next decades, 2 decades at least. And if we make sure, first of all, that those transitions are people-centred, we're creating jobs that are safe and as doing it in a way that's as inclusive and fair as possible, I think will go a long way towards embedding the importance of engineering even more.
Thank you, Tim. And also I'll do a little name check for the Academy's This is Engineering campaign, which of course has been our major effort. It's an industry-wide campaign to try to change perceptions of engineers and the role they play and who engineering is for. So look it up if you haven't come across it. It's an open source campaign and we'd love everyone to use the resources. Dorothy, I'm going to come to you. Professor Ishaya Dagwa has asked us a really important question. We're talking about learners. What plans do we have for supporting the people who have to train and teach them? And maybe we can, whilst you're answering that, also just ask you to give a bit more information about the mention of VR that you made earlier on. So David Adkins is asking about the kinds of concrete examples of tools like VR and virtual reality and other similar technologies that can be used to help us be more effective and more efficient in the way that we educate and upskill people. So Dorothy, over to you for that.
Yes, thank you very much for this. I think Professor is very right, as he said, that you cannot give what you do not have. So I know a lot of times when we talk, we speak a lot about the students, but we need to also work with what about us, the faculty. So I just share two examples from what we are doing at Makerere University in the engineering program. So we are just working on a competence-based assessment. We've just developed a competence-based assessment framework for our engineering programs. Again, we have this big UNESCO project we've been working on for some time. But the first step is working with our faculty and key stakeholders as well, in terms of onboarding this, getting any further input, getting guidance in terms of how we should actually roll out this framework, so that actually they are well capacitated to be able to deliver on this, to be able to speak about why this is important, later on being able to deliver on it. So we also have some programs for the students because, in engineering, I don't know, I'll speak about Uganda. In engineering, the best students typically will come in for engineering. But in order to have been the best student, you have done a lot of book reading, okay? You're very, very good with your theory, all right? So you've got top grades and everything. You come in, government scholarship, all that. Now, engineering is the doing work. So when we say that actually we are going to score you higher on what competences you can demonstrate vis-a-vis how well you can replicate a textbook. There's that dynamic that we also have to work on. So we have to work with the teachers and training, very, very important, and then also with the students. The other example I can share is on the issue of soft skills, because in the labor market analysis that we did, the issue of soft skill came out very prominently. And for engineers, this is an issue because, again, as engineers, our keeping thing is, we do things, we tie up things, we fix things and all that. Emotional intelligence, speaking to people and all that, that has not really been our strong forte. And again, what we are doing is we are working with a partner to first equip our faculty. Why is this issue important? How do we go about it? How would they actually be able to facilitate sessions? We're going to use an online facilitated program to do this. But the first step, the first point we're starting with is the faculty, so that we can get them comfortable with the whole space and then facilitate them to be able to deliver this training. The program actually will be self-paced for the students. But it's important that the faculty are able to, first of all, appreciate the platform and all that. And actually, this is also an example that I'm giving in terms of an example of technology tools. This particular one we are doing with we're collaborating with the Wadwani Foundation, and they have a platform that looks at both employability skills for those that are our students going out and for the fresh graduates. So there are tools and platforms out there depending on what an institution's need is. And I would really encourage colleagues and other faculty on this too. Before you, and engineers, we don't like reinventing the wheel. Before you actually go out and do platforms like this yourself, first check and see what is out there that you could adapt to your local circumstances. Because if I may take a few moments as well and maybe build on what Tim had also shared earlier, what do we need to do to make engineering really speak more to our communities? I think looking at what works for us is therefore very important. So if you look at the case of Uganda, the way we are speaking to engineering is that, yes, you learn all these things, you can do mighty and brighty and all, but let's look at what we as a country needs. And our country has been very clear on our key priority areas: commercial agriculture, all right, industry, right, ICT skills, services. If you look at all those spaces, all right, and dig the next level down, you'll find that engineering is actually the foundation. So we're speaking to our students, our faculty, that yes, we're doing engineering and it's really great to do engineering, but why are we doing it? Okay, we need engineers in commercial agriculture. We need a lot more mechanization on our farms than we currently have. We need a lot more collection of the data. So using IoT and AI to process what we have. So we are bringing the technologies, even the emerging technologies, but putting them in a context that can help everyone. And in fact, for my students, my mantra is that, you know, if each of us adopted our villages, because when we move around in our villages, they're so proud to showcase the engineer we have in our community. Even our first year students, and I tell them, none of them has yet come back to tell me that they say, no, don't call me an engineer yet. You know, I say, no, is that fair enough? But what role are we playing in solving the local challenges? How are we taking advantage of the local material, locally available materials, and therefore helping engineering not look like, yeah, engineering is good. It will take us to the moon, and we're also in the satellite wars and all that. It's good as a country, we are there. But how does our community feel the sense of an engineer, feel the value of an engineer within our respective communities? Thank you.
Thank you, Dorothy. That's very powerful. I love this, focusing on the why and ensuring the relevance to local need. I'm going to come to you, Rose, in just a second to ask for any examples you have of using VR or any other technologies to transform learning. And also, Nigel Hargreaves has asked a secondary question about systems thinking, which is, of course, one of the classic engineering habits of mind, and how we can really optimize the use of that and foster that skill in our learners. And then just a heads up to all of you that because we've been having such a marvelous time, we're actually coming towards the end of the allotted session. So I'm going to suggest that once Rose has had a good go at that question, we can actually move to Meredith Ettridge's question, which is, I think, a good way of trying to summarize of all these broad and wide-ranging issues. What is it that you would really love to make happen? So Meredith's question is, the challenge is so large and multifaceted. What one thing would you wish to happen if you had that proverbial magic wand? So I'll let you, Tim and Dorothy, ponder on that. And Rosie, you'll get to have the last word on that. But first of all, could you just give us your thoughts on, innovative technology enhancing the way we can learn and teach, and also the role of systems thinking and how we can optimize that? Thank you.
Yes, we are doing things on virtual reality. So I'm currently working on an Innovate UK project, looking at battery training for the battery workforce of the future, working with Cranfield University and Warwick Manufacturing Group, and looking at how we use VR. We know the chemistry end of battery manufacturing, that's pretty dangerous, and we know at the other end we've got high voltage, so they're pretty dangerous spaces to work within. So using VR really does help for you to practice those behaviors and to think about how that works. So certainly Cranfield are thinking, we're doing this for one application, but how do we scale this up? What other applications can we use it for? VR has been really well developed for welding, and VR welders are really popular now. Again, we don't have enough welders in this country. We need more of them. And again, we need to support the workforce to develop in terms of instructing those. So it absolutely is developing, and it's particularly in those safety critical areas that it's most useful, I think, to practice those behaviours. In terms of systems thinking and agility in learning, I will come back to the Institutes of Technology because I think, and we've had some feedback on this, So I work with the Institutes of Technology, but I also work at a university that has an FE college. And I think by bringing learners together at different levels to work on projects, they gives them different perspectives, and from different institutions, and bringing employers in, it starts to get them thinking in a different way. And that might be simulated learning for them, but it starts to get them thinking in the ways of work. So where we've got training civil engineers working with plumbers and electricians and carpenters, actually they're thinking realistically about what their designs are going to look like in reality. So I think there's more that we can do, and we are hearing more about that from potential new governments in the UK around colleges, further education and higher education working closer together to support sectors such as engineering, which is a high priority.
Brilliant. Thank you so much, Rosa. I can't believe how the time has flown past, but don't worry, we're not quite at the end yet. And I'm looking forward to hearing your words of wisdom now about that one thing you'd really love to make happen. So Tim, I'm going to start with you. Tell us what you can do with your magic wand.
Well, if we're in the realms of magic and fantasy, I'd love to have a bit of a pause so that we might just redesign the engineering education curriculum from scratch. We've all talked about the need for encompassing a broader range of disciplines, combining multiple disciplines. I think there's another element we're missing as well, which is how, and it's happening in some places, how we can get learners to work with other folks with other skills. I think that's a key area, particularly for engineering. One of the frameworks that I've started looking at recently and really started to enjoy in terms of being able to do that, and it speaks to the soft skills element of our discussion, is the RSA's Capabilities for Life framework. So I encourage folks to look at that. And then just a plea to Rosa for the future. I'd love to learn more about the VR tools that you've been designing and implementing. I am aware that in the context of engineering education, we've got lots of studies that have attempted to explore the effect of virtual reality on teamwork and engagement and motivation and things like that. So in wrapping everything up, if there's an ideal VR solution that enables a better curriculum that's fit for the future and allows our engineering students and engineers of the future to work multidisciplinary with lots of other disciplines, then that's the way forward as far as my magic wand is concerned.
Thank you, Tim. You managed to cram quite a lot into your one wish, so well done.
Thank you.
Dorothy, I'm going to hand the magic wand to you. What are you going to do with it?
Wow, I've been thinking, and my list is very long, but I thought I could summarize it in one word. Okay, 2 words. Stronger collaboration. All right. Now, the big piece. Stronger collaboration between academia, we in academia, industry, right? Our professional engineering institutions and government. All right. The three of them working closely together so that we can have engineering training programs. Yes, our mainstream curricula and every other thing that we need to do to bring in agility in order to solve local problems, so that irrespective of what engineering stream or field you are in, you can really see that you're contributing to the national development. And this is why we need that strong collaboration, tighter than we have right now, among these key stakeholders, so that we can drive engineering training and enhance engineering skills and have a better match between what we are generating and what these different players need from us. Thank you.
Brilliant and admirable that you could sum it up in 2 words. Well done, Dorothy. Thank you. And Rosa, you get the final opportunity to wave that magic wand. What would you like to do?
With my magic wand, I would like to create a gender balanced workforce. And I think we haven't really touched on that, but I think that would really drive forward, to put us into a different space in terms of how we engage with young people, how we really take things forward, and would really be more representative of the general population. So we should also find some better solutions to the challenges that we'd face. So it's quite a big ask.
Well, I think it's great that you brought that in right at the end, but you're absolutely right. It wouldn't be a balanced conversation on engineering skills if we didn't mention the lack of diversity and the need to tackle that. And the engineering capability review will give some broader context for that, so people can understand where different countries sit in that sense, which I think will be really interesting to everybody. But I would like to thank you all for such a stimulating discussion. When you pick a topic like this, it's almost impossible to do it justice. There is so many different places we can go. But I think, what we heard very clearly from you all is that the world is changing. It's changing fast. That impacts on engineering as much as any other profession. But there are lots of things that we already know can help us in responding to that. We've talked about the importance of why engineering and why these kinds of new skills that we need to develop, and never losing sight of that and the relevance to society. We've talked about the role of collaboration and partnership, especially with industry, but also with trade bodies and with government, as a means to helping us navigate this complex and ever-changing world. We've talked about technology as both an imperative for and an enabler of change. And we've got some specific examples of how it's already being used. I think probably we should be promoting more widely, because I think there's still a very mixed understanding of what these technologies offer today, rather than just down the line in the future. We've also talked about the importance of shifting behaviours and mindsets. And that means at the individual level as well as at the professional level and at the educational level. So we're all going to have to get more comfortable with the fact that continuous upgrading of skills is going to be a part of our lives. And in some respects, that's quite exciting. We're going to have the opportunity to have different career chapters and to continuously learn. But we need to make sure that people are supported in that transition, which will feel more comfortable for some than others. And then last but not least, we've talked about how important it is to really make sure we get the message out there that engineering is for everyone, and to open up our profession to talented people from all parts of society, and to make sure that whether they're entering through a vocational route or an academic route, that they are welcomed in and that we celebrate that. So thank you everyone for your brilliant questions that prompted some very interesting discussions. I hope you enjoyed it. If this conversation has sparked your interest, or you have any further comments about today's event, please do take a moment to respond to the survey that should have been posted in the chat or will be done shortly, and will also be emailed to you following the event, because your feedback helps us to shape and improve events that we run in the future. I'm delighted to say that autumn will see the launch of a special 3-part mini-series of critical conversations focused on engineering and a just transition to net zero. We know that engineers are integral to demonstrating how we can achieve socially, societally beneficial outcomes. We also know that achieving these outcomes requires really thoughtful engagement with wider society. So in this critical conversation mini-series, we're going to be exploring the role of public dialogue in informing engineering's response to the net zero transition, and which pathways we might want to take. And I'm delighted that the questions that we tackle in those sessions will, of course, be shaped by public input. The events are going to focus on energy, transport and built environment, with the first event in the series, Energy, Decarbonising Equitably, Effectively and Democratically, scheduled for Thursday the 5th of September at 6 p.m. There should be a registration link in the chat below, and I really look forward to seeing you then. And you can also catch up on previous critical conversations via the LinkedIn chat below, and stay tuned for other critical conversations on LinkedIn Live. But thank you for now. Thank you to our fantastic speakers for joining us, and all of you who took the time to listen and engage. I hope you have a great evening or morning, wherever you are, and we'll look forward to further critical conversations in the future. Thank you.